So we're looking at transforming the cubic root function. The most important point in this one is this point here. We call this the symmetry point. We got a couple of points we can use to help us transform it. This one here is 1, 1. There's another one here at 2, 8. And then obviously there's one at 3, 27. Usually we're drawing a smaller graph than this. So use these points to help you transform it. So we need to have a go at sketching this function. What transformations can we see in the function here? What transformations can we see?
Isn't that point supposed to be 8, 2?
It is. It is. Thank you. Thank you. I always appreciate it. 8, 2. You can see why I say 2, 8 when we look at the cubic function. But yeah, always forget.
So numbers for transformations.
So we can use these points to help us with our transformation. What transformations do we have? We'd like to go to this one as well. So thank you for correcting that.
Vertical translation on unit up.
Vertical translation. Which order will they occur in?
First would be order of operations. First one's in the radical. So first the horizontal shift 3 units right.
3 units right, horizontal shift. Perfect. Next.
Then it would be a vertical stretch by scale factor 2.
Vertical stretch, scale factor 2. And lastly,
then the vertical shift 1 unit up.
Okay. So let's start off with our point. So our symmetry point is always going to be at h, k. So let's start off with that one. Where is h, k going to be? What is the value of h? 3. And k? 1. So it's going to be here. There's our symmetry point. So the point 1 across from that is going to get moved up and doubled, isn't it? So it's going to be at, so normally it's here, it gets moved up to there, but then it gets moved up one more time. So it gets moved up to here. The point to the left of it is also useful. That's going to go and be here. So our function is going to look something like this.
So if you want to do one vertical translation on your part.
Haven't I done that?
No, because it was 3, 1, and then the vertical stretch will end up at 4, 3, so it should be at 4, 4. Because you have to move up 1.
It's at 3, 1, and then with the vertical stretch goes to 3, 2, and then with the vertical translation goes to 3, 3.
Doesn't go to 4, 3. It goes like 1 to the right and 1 to the left.
Yeah, it's there. So look at
Oh, sorry, 4, 3. I read it in the right place.
So that's with all the transformations.
Yeah. I believe so. Let's try it. You can always use the other technique where we find y of. We definitely know it's going to be at 4. No, we can see there's no horizontal stretch or compression. Let's try y of 4. We've got 2 cube root of 4 minus 3 plus 1, which is 2 plus 1, which is 3. So 4, 3. Okay. Have a go at sketching this one. Ooh, these could be my originals. Sorry. These look like my originals.
The same point I just with the wrong one.
Isn't it like this? Isn't it like this?
It's a straight line. That's it.
It's so straight.
Anas makes it in before 8. Let's hear it for Anas. Whoa. Improvement. All right. Where is going to be our symmetry point? Where is going to be the symmetry point? Let's have somebody fresh answer this question. Let's have somebody fresh answer this question. Who doesn't normally answer a question? Due to part-timer, that will do. -1, -2. All right. You know me, I hate horizontal. I hate horizontal stretch and compression. Let's do this one. I'm going to use the cheaty method. So I want that number to disappear. I want 8 to disappear. I'm going to put in an x value and just evaluate where it is. What x value would make that 8 disappear? 7. Let's go for a 7. Let's try y of 7. Oops. Y of 7 is equal to the cube root of -1 over 8, 7 plus 1 minus 2. So this becomes what? This becomes 8. 8 cancels that, so we get -1. So we get the cube root of -1. I want to show this. I want to show this. Can we take the? We can't take the square root of -1.
Who can take the cube root of it?
Why can we take the cube root of -1?
Because a negative times 3 can still be a negative.
Any number times 3 can still be a negative.
You know, if you multiply a negative 3 times, you'll get a negative. So it's possible.
You can multiply any number 3 times or twice. So you can times -2, but twice, like 2 and then 2, and you'll get -4. That's a negative. Go on, get it right.
Okay, multiplying 2 negatives gives you a positive, and then you multiply another negative, and a positive and a negative make a negative.
Not yet. You can multiply any number by itself 3 times and get a negative. By itself.
By itself. Oh.
I'm writing you. I'm being difficult. All right. So where is this point? What did we put in? We put in 7. We got -3. So 7 minus 3. Ooh, what's happening here? What's happening here? Reflection across the y-axis because of the minus sign inside the bracket here. So just using symmetry, where would the other, without calculating, where's the other point going to be? This distance here is 8, so this distance here is 8. So we're going to be at -9, aren't we? This distance down is 1, so this distance down is 1, so we're going to be there, aren't we? Use the symmetry and just reflect it without doing any hard work. Try it. We shouldn't do hard work, but try it.
So if you made it, can you make it a vertical stretch or a compression by 1/2?
Yes.
So then how would you?
But you can't take the reflection out.
Yeah, the minus would still be in there, but there would be 1/2 outside.
Yeah. So this point here is going to be at 1/2. This point there is going to be at 1/2. If you're working with the stretch, you're working at 0.1 to the right. Yeah. Sorry, it's a 1/2 down. That's what I mean. So it'll be at -2.5. Okay, what's up next? Ooh, write the function. Write the function. Happy days. You want to go straight at it?
Yes.
All right. That's what I like to hear. That's C block for you. A block. You guys want to sit down and watch me do it? Just pause the video and wait. Okay, so we start off by finding our symmetry point. We look at the scale here, that's a 2, so this is a 1. So this is a 7, this is a 6 there. So we are at 1, comma 7 there on this axis. So we get g of x is equal to a bracket cube root x minus h plus k. We then take this next point here. This point is going to be at 2, comma 9, isn't it? 2, comma 9. I think it's 2, comma 9 to me. So we put those values in. 9 equals a cube root of 2 minus 1 plus 7. So we get 9 equals a plus 7. A is equal to 2. So finally, g of x is equal to 2 cube root x minus 1 plus 7. Anas?
So what happens with the cube root minus 1, 2 minus 1?
2.
Because you skip from that straight to
All right, 2 minus 1 is what?
1.
What's the cube root of 1?
1. Oh, okay.
Do you take coffee?
No.
You should start. At 7 o'clock, double espresso. Maybe you'll be with us by lunchtime. Have it.
What's it? Do we have to put the equal, like, triangle?
Equal triangle thing.
Application.
The implication symbol after you equal to.
I don't know, it just makes me look clever. The whole purpose of math is to make other people feel intimidated and to make us look more clever. Don't you use this normally in your lives? We like it to look really clever. Intimidating, isn't it?
Yeah.
That's the purpose of math. To separate us from them. Same reason in English for having really big words, like defenestration, things like that. That means to kill somebody by throwing them out the window.
Why is it always good?
I don't know, it's pretty popular, right?
Did you know
Although
that?
I think it was a Dutch monarch that was first killed, defenestrated. I think it was a Dutch guy, somewhere around that part of Europe.
If you get shocked, unless it kills you, you didn't get electrocuted because electrocutes a portmanteau.
Yeah,
electric and
Yeah, you got an electric shock.
yeah, just not electrocuted.
Of course, everybody knows that.
One day I'll get you. You'll be wowed by a special fact of the English language.
In math, you can focus on the Latin plurals, like, you know, axis and axes. Some good ones as well. Singular bacteria.
And is that singular bacteria? Is it just bacteria? Bacteria?
Bacteria.
Bacteria.
Bacteria?
Yeah. What about criteria?
Criterion?
Um,
Um,
only criteria.
So we find B like how we found it.
Yeah.
Is it the same as A?
No, it's the cube root. Well, no, A is the cube root of B. It's the cube of A. Or 1 over the cube root of A.
If A equals the cube root of 1 over B.
Yeah.
So I say A and I find B.
Yeah.
Sorry, pause. Ooh. So, what is the coordinate of our symmetry point this time? 2, 1. So we get, let me write on the graph at this point here is 2, 1. So g of x is equal to the cube root of 1 over b x minus 2, close bracket, plus 1, yes, plus 1. What is the coordinate of this lovely little point?
5, 2.
5, 2. I'll go for that. So let's pop them in here. 2 is equal to the cube root of 1 over b. And then inside the bracket, we've got 5 minus 2. That's an ugly number. Why have we got that number? Why have we got that number?
Because the question from my
Okay, let's see where it leads us. We've got 3 over b cube rooted plus 1 equals 1.
That would be easy to
there we go. So well, let's cube both sides. We cube both sides, we get 3 over b equals 1 times b up here, so we get b equals 3. G of x is equal to, sorry, can we chat about this? This isn't IM3 regular. We should sit in awe of the mathematics in this class. Ooh. Wasn't it really? No. I didn't. I'm not surprised by that. Did you help it?
Yeah. So it's the 2 plus 1 is plus.
All right. One other little bit of piece that I heard you guys chatting about. If we have a cube root x minus h plus k, and this is equal to cube root of 1 over b x minus h plus k. What is the relationship between a and b? What is the relationship? Let me give you guys a minute or two. So let's have a little formula. A is equal to what? B is equal to what? In terms of A is equal to what in terms of B? B is equal to what in terms of A? Yeah, just B. Okay, let's take the right-hand side. The right-hand side is the cube root of 1 over b x minus h plus k. So this is equal to the cube root of 1 over b, cube root of x minus h plus k. Is that right?
What is the right hand side?
X minus h plus
So what is the right hand side?
I like this stuff there. It's easy. It is, yeah.
Can we know that you can't see both of the equations at the same time?
We're not. It's not a show that question.
So you don't have to.
It's not a show that question, is it?
Isn't the opposite like 8 cubes equals 1 over b?
It's actually like 90 people.
Isn't it?
I don't know. Check my math. Usually the math speaks for itself.
But it's also 8 cubes equals 1 over b, right?
It depends. Yeah, but it's all right. If you do like equation,
I think the last thing you did
or if you do like
equals 1 over 8. 8 cubes equals 1 over b. Why did you do this?
Yeah, that's good. All right, that is it from me today. You've got a practice question. There's no Excel on this one. That is it.